Hey guys, welcome to Safi Mixed. In this video, I will let you know how to remove noises from data in Mathematica from a nested data. You see here I have a table of data which is in the form of nested data, and if I plot this data like I have plotted here, you see here is a lot of noise in this region that is happening from something 1.8 and more, and I want to remove this noise from my data. I want to restructure my data by removing this noise, and for that I need, since if I look into it, this is a kind of linear increase, and then it has become flare. So I want to add a linear increase at this region and then get the data flat in this region. So that I can do by first estimating the slope of the data, and you can see I can estimate the slope in this region from 1.2 to somewhere 1.4 or 1.8 or 1.6. So I go back to data and look at the position of 1.4, this one, and then I take this data. So I copy this data, and I come down here and I paste the data over here. Now I just subtract this the two less from each other, and from this I can estimate the slope. So the change in x value is this, and the change in y value is this. So I can estimate from these two values by dividing the y value with x value. I ignore the minus sign because I have subtracted the bigger values in this list from the smaller values in this list, so that doesn't make any difference. And I can divide the value 0.0253. I go to 3 decimal and then 0.066. So it gives me an estimation of the slope, which is 0.37. So I use this estimate value of the slope and construct a rule for my data. I call it rule equals. I first define the structure of my data, which is this, and y underscore. This is the structure of my data because in each sublist there are two values. And now I replace this value with conditional values. I call it replace x, and on the y value I put a condition, the f condition, and I ask the data if 1.4 is lesser than x, and x is lesser than 2.5, let me call it. I can change this value in time, and then I ask to set y equals the slope 0.37 times x, because it is linear in x with this much slope. I have estimated the slope, and then there is so it would put this linear value in this region, and then I set the flat value, and that for that I put another condition in the if condition, and I ask the condition x greater than 2.5, replace the value of y with an average value of 0.85, and then leave the rest of the value of phi as they are. And I then close the bracket for the first if condition, close the bracket for the second if condition, and close the curly brackets for this. This is my rule. And now I want to plot my data through list plot, and I name the data which is list 1, and I then ask Mathematica to replace the rule for this data, and then I join the plots, the points true, and I plot the range of plot range all. And if I now run this, I first select the whole data and then I run it. I get this plot, right? But you see there is a little hunch in this region. I want to remove this, and again there is a big drop in this value. I want to remove this, so I first want to remove this, and that I can easily do by changing this value from 8.5 to, let me add this to 8.8. If I run this and I add, but it is still a little smaller, therefore I replace this with 9.2, and then yeah, now it is okay, or I can change this from number 9.2 to 9.3, and if I run this, now it becomes flat, and from here there is the slope is somewhat larger. So what I do, I let me change the lower limit, or let me change the slope from 0.37 to 0.5. If I check this, what do I have? Yeah, now that's all right. It's almost okay. I can reduce the slope to a little more by 4, 5. And now if I check this, yeah, it is okay, but I have a problem in this region now. So I need to shift this a little more ahead in order to keep this region straight. So what I do, I change the upper limit from 2.5 to 2.55, and then I would do that same over here. I can add an equal sign over here so that it could join the two region, and I set this to 2.5, and now if I run it again, there is an abrupt increase. So instead of 2.55, I change the upper limit to 2.6, and then I'll do here as well. So I take this to 2.6, and if I run this now, okay, again there is a little, so I change this to 2.7. Let me check this to 2.7. So I'll put this value of x to 2.7, and now if I run it, okay, that's fine. I have changed the noisy region. I have removed the whole noise in this region to correct the data into this form. There is a uniform linear transition, and then it becomes flat. So this way, with this one line command, you can remove the noises from your data, from your nested data. And thanks for watching.